In this video, I'm going to walk you through how to change the router ID on a label switching router. Let's begin. When a router is running MPLS, it's going to have something called an LDP Router ID. LDP is the Label Distribution Protocol that's turned on automatically when you enable MPLS on this router and its interfaces. Now this router ID, if you're familiar with how OSPF chooses its router ID, LDP uses a similar function. If we have manually configured the router and told it, hey, use this interface, or use that interface, or use a loopback interface, and the IP address sitting on that interface as the router ID, that's exactly what will be used first, a configured router ID. Secondly, if there is no configured router ID, it's going to use the highest IP address on any loopback interface the moment that LDP comes up. In the event that we don't have any loopbacks, then as a last-ditch effort, it's going to use the highest IP address on any of the other interfaces. And that's how it chooses the router ID. Now we might say, well, so what? What do we care if it chooses this interface or some loopback as a router ID? And the answer is, in the hello messages that R3 is going to send out to R2 and R4, it's going to use the router ID, that IP address, as the transport address. And if it's not reachable, that means that R2 or R4, if they can't reach that transport address, which by default is going to match the router ID, they won't be able to become LDP neighbors with R3. So what I thought would be fun for us to do in this video right now is take a look at how we can verify and view what the LDP router ID is on a router such as R3. And then secondly, I'd like to walk you through how we can change it. So let's start off by asking R3 exactly what is its LDP router ID. Now there's several ways of seeing that. One method would be to use the command show MPLS LDP discovery detail. That would give us that information. So right here at the top is showing us that the ID is 3333 and the :0, the 0 represents that we're using system-wide label space as opposed to an individual set of labels per interface. Now as R3 sends hello messages out gig 20 and out gig 30, in the payload of those little LDP hellos, it's advertising that the transport address, which means the address if you want to connect to me, says R3, is 3333, which matches the router ID. So we're advertising that out gig 20 to the left and also out gig 30 to the right. So anybody who wants to neighbor up with R3 is going to be trying to connect to that IP address. Now, what I'd like to do next on R3 is a couple things. One, let's create a brand new loopback interface with an IP address, and we'll also add that network into OSPF. Because if we have a router ID that's not reachable by its neighbors, we won't be able to form LDP neighborships with those neighbors. So in this case, we're going to use interface loopback 8. We'll give it an IP address of 8.8.8.8/32, and in interface config, we'll just pop it right into OSPF as well. I also think it would be wise just to validate that it really is participating in OSPF, so we'll just do a quick verification with a show IP OSPF interface brief. And sure enough, there we have loopback 8, and that address indeed is part of OSPF. And the most important reason for that is that we need to make sure that R2 and R4 can reach this IP address, because once we set the LDP router ID to that, that's going to be the transport address that R3 is going to be saying he should be reached on as he sends his hellos. Now to force the router ID to be that IP address on loopback 8, we're simply going to use the command MPLS LDP Router ID, the interface, in this case loopback 8, and the keyword force, which basically says, get busy, let's set that LDP router ID right now. Now any existing neighborships, like the one we had with R2 and R4, those are going to be removed. And check this out, because that 8.8.8.8 address is reachable from R2 and R4, they were both able to form sessions with R3. And what's happening really behind the scenes, the device that has the highest router ID actually initiates the sessions. But because R2 and R4 could reach 8.8.8.8, when R3 went over to initiate the sessions, R2 and R4 were both able to reply, and the sessions were successful. If we wanted to verify our router ID, it'd be really simple. We do the same command that we did previously. We'll just add the do keyword in front of it because we're in configuration mode. And it should show us not only the interfaces that are participating with MPLS and LDP, but also it should show us what the new LDP router ID is, which is right here. And you'll also notice it saying, yeah, and by the way, I'm advertising in my little LDP hello messages, I'm advertising that the transport address is also 8888. And because that's reachable by R2 and R4, it's not causing a problem. It's not breaking the MPLS path. And if we just wanted to verify our neighborships, we could also do a show MPLS LDP neighbor, and that would also help us verify that our LDP sessions are in place. with R2 and with R4. I've had a blast, and I'm glad that you have joined me for this video. If you're interested in learning more about MPLS, hey, come and check out our latest courses up at CBT Nuggets. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.